Okay, this is the P4 paper from June 2021. It's question number 5, and if we look at it, we can see that this is a differentiation question, and in particular, I've got an implicit function there, so it's going to be implicit differentiation. Okay, so when we're doing implicit differentiation, two things to remember. If I've got any function where I've got y involved, then differentiate it like you would normally, multiply by the power, take one off the power, but then we need to add in a dy by dx, so that would differentiate to that. And if we've got a situation here where we've got a products, we're going to call one of them u and one of them v. If we do have that situation, then I do need to remember that the differential of a product is u dv by dx plus v du by dx. Now it's up to you how much of this you want to show in your working out in terms of keeping the timing right for doing the question, but not making mistakes. At this level, I would hope that most of you can do this without necessarily writing all that down. I'm certainly going to do that. If you want to spend a little bit more time on this implicit differentiation, go and have a look at the how-to videos, and then we can do it in a much slower version there. But in terms of, for this question, right, what are we going to do then? So let's get on and differentiate. The question is to find dy by dx equals. So what I'm going to do is look at the original function, y squared equals y e to the minus 2x minus 3x. Okay, so differentiating y squared, that's no problem. Multiply by the power, take one off the power, and then because it's a y function, have dy by dx is equal to, so this bit here, I don't necessarily write this in, this is just explaining it to you guys. I'm going to get rid of it from my answer in a second. If I've got u and v there, and I'm using the idea that it's u dv by dx plus v du by dx. So u dv, well, u is y. dv by dx is just the differential of e to the minus 2x. And again, you should be able to do that at this stage of going through and doing that. Differential of e to the minus 2 is minus 2 e to the minus 2x. Now, just be careful about making sure we understand what's being multiplied. That's not y minus 2 lots of it, it's y multiplied by that. That's my u dv bit done. I now need to do v du. Well, v du is going to be, v is e to the minus 2x, and du is the differential of y, which is just dy by dx. So we've now completely finished with the product part there, and as I say, you could have that in there if you want to. It doesn't really help me. I don't tend to make mistakes with these. So I've done the product part. We're now just differentiating the minus 3x. Differential of minus 3x is just minus 3. So all I now need to do is to get this to be dy by dx equals. So if we just multiply everything out and tidy it up, I've got 2y dy dx. I've got minus 2y e to the minus 2x. And I've got e to the minus 2x, dy by dx, minus 3 here. So what I now need to do is to get the is to get the dy by dx's on one side and everything else on the other. So in this case, 2y dy dx minus e to the minus 2x dy dx is equal to minus 2y e to the minus 2x minus 3. I've simply moved this thing over to the other side. Now that I've got the dy by dx's both on the same side, I can factorise and take that out as a factor, which leaves me 2y minus e to the minus 2x is equal to minus 2y e to the minus 2x minus 3. And so then dy by dx is equal to minus 2y e to the minus 2x minus 3, all divided by 2y minus e to the minus 2x, like that. And then if we look at the answer, yeah, that's not a surprise. On the top here, they haven't got any negatives. So if I just multiply everything by minus 1, multiply the numerator and the denominator by minus 1, I actually get 2y e to the minus 2x plus 3 on the top. But in order to do that, I need to just flip the denominator e to the minus 2x minus 2y. So I've only written it like that because that's actually what they were trying to get me to do in that first part. So we've got the differential, and now what? So now it says the curve crosses the y-axis at the origin and at a point P. Okay, so it's going to hit the y-axis twice. Tangent to the curve at the origin and the tangent to the curve at P both meet at a point R. See if we can find the coordinates of R. Right, okay, I'll do a quick sketch. I don't know how useful the sketch is, simply in terms of I don't know what this function looks like. I'm not going to pretend to get it right. I'm almost just going to try and use the information they've given me to sketch something out. And what they have said is, well, let's just move that down a little bit, is they've said this function hits the y-axis twice, and one of those times is at the origin. So that's O, and that'll be the point P where it hits it again. And they've then said that the tangent at the origin and the tangent at P then both meets at this point R. This is only a possible diagram, okay? This is not absolutely 100% in stone as to what the diagram could be, but it might help me now to try and work out what I've got to do. So what I'd like to do would be to find the equation of OR and the equation of PR, and then put them equal to each other to find out where they meet. So if we think about the equation of OR, we've got, for OR, let's just say down here, for OR, we've got that x equals 0 when y equals 0. So what I can do is I can use the fact that dy by dx is equal to whatever it was up there. Just going to copy that over. dy by dx is equal to that. So what I can do is I can find the gradient at the point 0, 0. So at the point 0, 0, dy by dx, which will equal the gradient of the curve, dy by dx is equal to 2 lots of 0 times e, well, it doesn't matter. So 2 lots of 0, it'd actually be e to the 0, which is 1, but that doesn't matter, it's 2 lots of 0, plus 3, all over e to the 0, well, e to the 0 is 1, minus 2 lots of 0, so minus 0 as well. So that's all going to work out to be equal to 3. So I know that the gradient of OR is equal to 3, but look, this is why it was worth drawing it out. I'm trying to work out the equation of a line that passes through the origin. If it's an equation of a straight line that passes through an origin, it's y equals 2x, y equals 5x, y equals 7x, or in this case, line OR is just y equals 3x. So that's really useful to make a start. Now, if I want to work out P is going to be when x is equal to 0, isn't it? So if I'm going to try and find out what value P is up here, we know that x is equal to 0. Sorry, this is the y-axis, this is the x-axis, isn't it? We know that that's going to be when x equals 0. So I can put that into the original equation. So x equals 0 for y squared equals ye to the minus 2x minus 3x. Well, if that's true, I get y squared equals e to the 0 would be 1. Sorry, that's minus 3x. E to the 0 would be 1 minus nothing. I'm actually going to get that y squared equals y. And if y squared equals y, I can work out what y is. Y squared minus y equals 0. Take y and y minus 1 out. We get y equals 0 or y equals 1. So going back up there now, I know that this is when y equals 1. In fact, I know that the point P then, so P is the coordinate 0, 1 there. So if I now want to find the equation of that line, let's find the gradient at that point. So gradient of OP, sorry, gradient of PR, should I say. I've run out of space here, so I'm going to have to do it here, I'm afraid. Gradient of PR, I want to do that, dy by dx is equal to, and again, remember, we're just using this function up here, but we're now putting in the points 0, 1 this time. So I'm going to get, it's 2 lots of, we're going to have 1 times 1 here this time, plus 3, all over 1 minus 2 this time. So that works out to be minus 5. I know that it's hitting the axis at 1, so the equation of this line is y equals minus 5x plus 1. So what I've now got is the equation of this line and the equation of this line. So using those two, I can just put them together to work out what the point's going to be. So if I, sorry, I've squashed this up a little bit, but I've got, for R, we're going to say it's where 3x is equal to minus 5x plus 1. That works out to be x equals an eighth. Y is 3x, so y equals 3/8. So my final answer is R equals an eighth, 3/8. I certainly wouldn't be suggesting that you put your work like that. It's only because I've run out of space on my actual answer scheme. But hopefully that all makes sense. Just make sure that you draw that diagram out because it really helps in terms of understanding what you've got to do. But that's that question all done.